Hi everybody. As I was working through, your submissions through Unit 4 and Unit 5, I noticed that there were some terminology uh, that could use some clarification. So I wanted to put together a short video. But as I was writing the script for the video, I realized it was going to go beyond the length of one video. So what I'm going to do is I'm going to cover critical thinking questions in this video, and then I'm going to have another video that discusses the activity 1 from Unit 4. Okay, so let's talk real quick. Variable. This variable is the cornerstone of programming. Okay, so a variable is a placeholder for data in a program. You're always going to need, in a program, you're always going to need to store, generally you're going to store something, some type of value, and you're going to need to store it in something. That something that you're going to store it in is a variable. Okay, so a variable is a placeholder. It just stores, it holds data. Okay, so some terminology that often goes along with variable, we talk about declaring a variable or to declare a variable. We talk about initializing a variable or to initialize a variable. Okay, so what does this mean? To declare a variable is just to specify to the program that you need it. You're just telling the program, I'm going to need this variable. You have to tell the program that you need it. Okay, so it's important to understand that programming languages declare variables differently. Okay, so in Python, you just name the variable. And then once you give the variable value, the value determines what type of data type the variable is. Okay, so you don't have to specify the data type. Instead, once you give a variable value, the value determines the data type. But now let's think about the programming language Java. Java, you must specify first the data type and then give a variable the name. You can't not include the data type. You'd get an error. Okay, so and then when we talk about initializing a variable is to give a variable value for the first time. Okay, so let's think of an example real quick. Let's say I'm having a program that gets user input about student information, and I'm going to collect these three things. I'm going to collect a student's name, I'm going to collect a student's grade, and I'm going to collect a student's GPA. I'm going to need 3 variables to hold those things. Okay, so I'm going to make a variable and I'm going to call it student name, and it's going to hold, guess what, the student's name. I'm going to have a variable called student grade, and it's going to store the value that I get from the user about that student's grade. Okay, I'm going to prompt the user, hey, what's the student's grade? They're going to put it in, and it's going to be stored in that variable student grade. And then finally, I'm going to have the variable student GPA, and it's going to store the value given to us by the user of the student's GPA. Okay, so that's just a quick example of a program that might have 3 different variables, 3 placeholders that will store value. One that will hold the student's name, one that will hold the student's grade, one that will hold the student's GPA. Now let's talk about data types. Okay, so data types is just a specification of the type of data that a variable can hold. Okay, so a variable can hold only one type of data. In Python, in Java, and most newer languages, you can't mix and match data types. Okay, a variable can only hold one type of data. Okay, so why do we have multiple data types then? It's for specificity. It's so that we can specify exactly what type of data is going to be stored here. It really does help for us to have different data types instead of one data type that is like a catch-all. It just wouldn't work. Okay, so common Python data types that you'll see in coding 1 include string, integer, and float. String, you'll note, is str. Integer is noted as int, and float is just float. So what do each of these things mean? String is so think of it as characters strung together, okay? A string is characters strung together. So those characters, it's important to note that those characters can be letters, numbers, and any of the special characters on the computer, on the keyboard, okay? So they are individual characters. When a program sees strings, it sees everything as characters. It does not see a letter. It does not see a number. It does not see a special character. It just thinks of them as a character. It's important to understand this because if you have two numbers, right? Let's say you have the number 7 and the number 3. They're next to each other, 73, in a string variable. That variable sees the character 7 and the character 3. It does not see the number 73. And therefore, you couldn't use that variable to do any kind of math operations. You cannot do math operations with string variables because strings do not recognize numbers as numbers. They recognize numbers as a characters. Okay? So then we have integers. Integers are whole numbers. So, and 0. All positive whole numbers, all negative whole numbers, and 0. Float are decimals, okay? So anything with a decimal. It's important to note that you cannot store a decimal, a float value, in an integer. It will give you an error. You can't, don't try. Okay, so let's go back to the student example. We had 3 variables. We had a student's name, we had a student's grade, and then we had a student's GPA. A student's name is a string of letters strung together, so therefore that variable type would be a string. A student's grade can be 9, 10, 11, or 12. 9, 10, 11, and 12 being whole numbers. Therefore, that student grade would be of the integer data type. Finally, we have student GPA. GPAs are stored as decimals, right? Even if it's a whole number, right? If you have a 3, you don't have a 3 GPA, you have a 3.0 GPA, right? It's always a decimal. So since it's going to store a decimal value, it's going to need to be a float data type. Okay. So when we talk about, there was a question in the critical thinking that asked about converting or switching data types. It's an important topic, but we're going to talk about it in the overview of the program, okay? So then let's talk about the modulus operator. This can be kind of a confusing thing. Okay, so it's important to note that the modulus operator is this percentage here. It only returns the remainder from integer division. And it's used with integer division, okay? They go hand in hand. So I think the best way to understand how the modulus operator works is to see examples of float division, integer division, and modulus, the use of the modulus operator. And I'm going to use the same numbers in all, okay? So I'm going to write on the screen. I'm sorry, but every time I write on the screen blips. Please forgive me, okay? So I'm going to use the same numbers every time. I'm going to use a 7 and a 2, okay? So as a float, I'm going to write 7 as 7.0, sorry. So 7.0, it means the same thing as 7 divided by 2.0. Okay, 7.0 divided by 2.0 is the same thing as 7 divided by 2. 7 divided by 2 is 3.5. So in this instance, where it's float division, that outcome can be a decimal. 3.5 is a decimal. It can be a decimal. That quotient can be a decimal with float division. Okay. Integer division. So same two numbers, 7 divided by 2. Okay. Integer division is dealing with only whole numbers, so, or 0. So the quotient can only be a whole number. It cannot have any decimals. So 7 divided by 2, using where the outcome, the quotient, is only a whole number, well, 2 goes into 7 3 whole times. Okay? 3 whole times. Now, let's talk about the modulus operator. So using modulus on 7 and 2. So we say 7 modulo, that's how we say it, 7 modulo 2. Okay? So this is, first it will do the integer division and then it will give us the remainder. Okay? So first we already know that 7 divided by 2 using integer division is 3. 2 goes in 3 whole times, but it has a remainder of 1. Okay? So we have 3 different things here. We have float division, we have integer division, and we have the use of the modulus operator. They all use the same numbers, but each of the outcome is different. An example of when we might use the modulus operator is, let's say we baked cookies. There was 12 cookies on a cookie sheet. You and 4 friends were hanging out one day, the day that you made these cookies. So you want to know how many whole cookies, not sharing, not breaking any of the cookies in half, how many whole cookies does everybody get? There's 5 of you, there's 12 cookies. You would use integer division. So 12 divided by 5 with integer division means that everybody is going to get 2 whole cookies. Then we would use the modulus operator to understand how many cookies are left. So 12 modulo 5 is 2. Okay? So there would be 2 cookies for everybody and 2 cookies left on the cookie sheet. Okay? So then finally, we're going to move on to the only question that I noticed seemed to need some clarification is this idea of a programming paradigm. So they don't really give you a definition very well of the term paradigm, but paradigm is really thinking, it's just really a different way of thinking, okay? So it's a way of thinking. So basically, we have these different ways of thinking with regard to programming, okay? And the 2 main types that you're gonna see, I mean, if you get into some really, really out of this world kind of programming languages, you might see different types, but most of the time the only 2 types you're going to see are called procedural and object oriented. Okay, so procedural, it's also known as top down. So it starts at the top and it moves line by line by line by line and goes through the program and until it reaches the end. Every once in a while, it may veer from there. Okay, so we have what are called functions or methods, depending on what type of programming language you're using. But so in those, you have this little piece of program that just sits off to the side. And it just sits there and waits until it is called. Okay, so let's say that the program starts from the top and it starts moving its way down, 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 down. It comes to this function call. So the focus goes away from this main program and it comes over here to this function. It does whatever is programmed in the function. And once the function is done, the focus returns back to the main program and it continues to move downward until it reaches the bottom. Okay, so it's very procedural in its working, top to bottom. Object-oriented, it's a little bit different and it's a little bit harder to wrap your head around. Okay, it takes people a little while to understand object-oriented programming. Object-oriented programming is really meant to more closely resemble the world around us through programming. Okay, so as you know, a data type holds a value, right? But that can be very limiting. One variable, one value. Sorry, not a data type. I screwed up. Variable. A variable can hold one value. So variable equals one value, right? There's that combination. But life doesn't exist where we can really explain things with just one variable, okay? So think of it like your student example. Object-oriented programming allows you to create an object of the student type that encompasses these pieces, all of these pieces. And so it's meant to create a more realistic example of the world through programming. Okay? Sorry this was long. Catch me in the overview of the activity, okay?